Alright, we've got another example here where the object of interest is made up of something that could be easily explained by a nice function. We've got a little parabola-like thing going on here. We've got a rectangular portion of the dam, and then we got water that's sitting behind this dam up to this height of 3 meters. We want to find two different things: the location of the centroid of the concrete dam and the location of the centroid of the water segment that is above the dam. Now, this is in the integral calculus side of things, and so you'd expect me to do an illustration of how to do all that with integral calculus, but at some level here, what I'm going to do is still think about chopping up my concrete into two areas, one that's rectangular and one that's the parabolic segment. Right, so I'm still going to do that even though we've got what looks like maybe supposed to be a continuous world. You're going to find in a moment I'm going to cheat even further and make you really mad. And that is that, alright, if we want to find, let's see, the location, the center of the concrete, we got to come up with a datum. Alright, let's use A as our datum, so there's your X and Y axis. So, let's see, if I only had the rectangle, it would be mid-height, mid-width. I've thrown out area to the right, so that's going to shift the centroid over to the right, and it's down lower, so I'm going to say that there's my centroid somewhere there. So I'm trying to find X bar and Y bar for the concrete dam. Whew. Man, this looks like this is going to be a long problem. And then we got to do the same thing for the water. Oh my goodness. Alright, well, let's get at it. Alright, and I'm going to cheat. I'm going to cheat because I'm going to use composite areas. I already know the answer for special parabolas here. So let's find X bar for the dam. Like, what are you talking about? Well, here's the deal. Our area is going to be the area of 1 plus the area of 2. Area of 1 is base times height. We know that. That's 1.5 times 4 meters squared total. Plus, we've already in another example proven that when we have a parabola that is got a base down here, we got the vertex, that area is 1/3 of the base times the height. Right? So because we have that special parabola, that's how I'm cheating. 1/3 of the base, which is 2 meters. The height is 3 meters. And I might be able to do this one in my head, or I might not be able to. 1.5 times 4 is 6. This is 2, so that equals 6 square meters total area. Cheater! Yeah, I didn't integrate this. Right? I did, I just knew what the result was going to be. Because I proved it in the previous example. Plus, you can look that one up in property tables. Right? Now, we want the first moment from the y-axis, so that's the sum of the x bars, ai's. I'm going to cheat again, because, let's see, this little individual one has that little, that's 0.75 meters times our, I think I did some math wrong, didn't I? This is 6, and this is 2. It should be 8 square meters. Oh my goodness. So that's 6 square meters. Plus, then our area here was 2 square meters. Now, the distance out to here, look this one up too. This is going to be at the 1/4, 3/4 distance left-right. Not the height part, but the left-right business. And I just know that because I've done it. I've looked it up many times, so you need to do that too. Prove it. Right, so 1.5 plus 2 over 4, which is another half, will get us 2 meters. Net there, so that's going to be 0.75 times 6 plus 2 times 2 equals 8.5 cubic meters. And so the x bar is equal to qy over a. That's 8.5 cubic meters over 8 meters squared. Now that I got the area correct, that's 1.0625 meters. It did shift over to the right. Not a lot, but it did shift over to the right. From, yeah, it did. I mean, it was 0.75 right? And then it shifted over by a little, little over a quarter meter, almost a little more than 3/10 of a meter. Right? Got to do the same thing for the Y centroid. And so its height for this rectangle is 2, well, the centroidal distance is 2, right? 2 meters here to here, times that area. Hey, I'm not going to live that one down. That's 6. Plus, and then again, if you go look this one up for that skinny portion, that's 3/10 of the height, which is 3 meters. Right? Got to look that one up. Times then the area, which we decided was 2 square meters. And so that's going to be an 8 plus 9/18 divided by 10, or 9.8 cubic meters. Right, so Y bar will then be equal to 9.8 cubic meters divided by the total area of 8 square meters. That's interesting. And so we end up with a height of only 1.225 meters from the base. Wow, that lowered quite a bit. We put a lot of mass that really sunk down from 2 meters at the rectangle, and then we lowered that thing down. So that is poor organization, because I found the Y bar here and I didn't label it. But there's at least your 2 answers, I think, unless you call in and tell me I've made some other goofy mistakes. Whew. Well, that's the portion for the concrete dam. Now, what the heck do we do about this parabola? Punt? Look it up? Cheat again? Well, alright, let's not cheat, but let's be a little clever. Right? Now, the portion we're talking about is just that area, right above the dam. Later on in you're going to find out why we care about that in the fluid statics portion. But we're looking for that little location right there. Right? Now the cheater part that I'm going to do is not to look it up, but instead I'm going to say, I don't like that one. So let's do this. Let's put the parabola over here. Okay? Because now everything's in the positive coordinate system. And then I'm going to be even more of a little cheater, because we want this thing up here. So now, why not take the rectangle and subtract off that one right there? Okay, in this one we have derived with integral calculus in a previous example. I'll let you go take a look at that. What you're going to find out is that this is at a 3/5, 2/5 kind of business on a height-wise, and then the left-right I don't remember. I have to look that one up, and maybe I got them flip-flop. But take a look in basic common properties tables for finding that particular one. You would derive it by this kind of thing. Take the whole minus the little skinny one and do it that way, as opposed to trying to set this up with a differential strip, which you could do here, but then you got to get that centroidal distance here, you got to get this height correct. It's kind of a pain. A lot easier to do this one, which you know already, and then to set this little one up like that, a lot easier to do.